All right, so this is the exciting part, the Wittig reaction. No, it's W, but it sounds like V. So Wittig reaction. And so the reason that this reaction is cool is that it's yet another carbon-carbon bond formation reaction. In this case, we're actually going to form a carbon-carbon double bond. But we don't have too many ways of making carbon-carbon bonds. And if you think about big organic molecules, there's a whole lot of carbon-carbon double bonds. So just a reminder, right there, we've kind of learned two other ways to make carbon-carbon double bond or carbon-carbon bonds. One was with the acetylide ion. So this can act as a good nucleophile and attack some alkyl halide or something like that to make your carbon-carbon double bond, or, epoxide ring opening, what have you. And then, of course, the Grignard one's also very powerful, so we can do stuff with that as well. So the Wittig reaction joins those powerful reactions to, again, create double bonds. And so what we have here is an aldehyde or a ketone, and it reacts with what's called the ylide or an ylide. So here it's a carbon-carbon double bond, and then there's other R groups on this carbon. And so what it does, it kind of fuses these components together. So this part right here stays there. And then the part from the ylide attaches onto it. And then in between is a double bond, right? And then your triphenylphosphine gets oxidized. So the PPH3 is a phosphorus with 3 phenyl rings on it. And then, of course, it gets oxidized. Now it gets the oxygen that came from the carbonyl. So as you can see or imagine, you can form all kinds of cool molecules with this. Let's just take a quick look at the mechanism. Overall, it's relatively simple. Note that you'll see two kind of forms of the ylide being drawn. They're just the two resonance forms. Sometimes you'll see it with this double bond. Sometimes you won't see it with the double bond, in which case the phosphorus gets the positive charge and the carbon gets the negative charge, because carbon is actually more electronegative than the phosphorus. Anyways, we won't take a detailed look at the transition state and the mechanism of this reaction. It's actually quite complex and beyond the scope of what we're going to do, but we're just going to simplify it and say that this carbon attacks this carbon, and then this pi bond attacks the phosphorus. To form this intermediate, right? Kind of this square intermediate. And then after that, basically these bonds break. One of them becomes a phosphorus oxygen double bond, and then the other one becomes a carbon-carbon double bond. And so what we've done there is fuse together our 2 carbons and then oxidize our phosphine. But again, really the power is the carbon-carbon bond formation. So we'll look at this in more detail in just a second.